Hello students, the previous class we discussed types of functions. There we discussed identity function, also constant functions we discussed. If a function f of x is equal to x, then if the function is of this type, then it is called an identity function. And in this case, we also discussed the domain of the function is real number set, and range of the function is also real number set. Codomain of the function is real number set, because we define the function f from set of real number r to set of real number r, such that the rule or the function f from r to r, f of x comes from this domain r equal to x, this x belongs to, that is the range, which is also belongs to the real number set. After this, we also discussed about here also we discussed the graph of the function. What is the graph of an identity function? Graph of an identity function is a straight line passing through origin. Previous class we discussed how to draw the graph. After that, we also discussed about the constant function. What we discussed there, f is a real valued function from the set of real number r to the set of real number r, such that if f of x is a constant, c is a constant, c may be a positive number, c may be 0, c may be a negative number, negative real number. You can take any value for c. If the function value takes this type, means is a constant, then it is called a constant function. And there we discussed the domain of the function is here, because we have defined the function from r to r, set of real number to set of real number. So domain of the function is r, and as you know, codomain of the function is this second set, which the function values lies, that is same here, that is a real number set. Then what is the range of this function? Range of the function, it is nothing but the collections of all the images of the function. If we will collect, then that is the range of the function. And in this case, whatever value you will take for x from this domain set, you will get this constant. Always you will get the value c. So range set is a set containing the element c, and depending on c greater than 0, c equal to 0, c less than 0, you can draw the graph of the function. When c is a positive number, as you have seen, when we draw the graph of the constant function, what you will find, you will get a straight line lying above x-axis, not passing through origin, lying above x-axis. Because f of x equal to c, that means this f of x also we can take, this is y equal to f of x equal to c. So this y value is the what lies in this codomain set. So y equal to c, when c is positive, that means y positive in your Cartesian coordinate system. So where y is positive, the values of y is positive only when it lies above x-axis. The values of y are negative only when it lies below x-axis. So accordingly, if f of x equal to c, which is a positive number, then you will get a straight line passing not passing through origin, rather it lies above x-axis depending on the value of c. Similarly, if c equal to 0, means y equal to 0, that means that is itself x-axis itself. So the graph is a straight line, which is the line which is the x-axis itself. If c is less than 0, then that means it is a y equal to c. So y is negative. Y negative means it is a straight line not passing through origin, rather the line is parallel to x-axis and lying below x-axis. So far up to this we have discussed. Next type of the function is polynomial function. As the name suggests, polynomial function. So if your function value takes the form of a polynomial, then the function is called a polynomial function. You know previous classes what is a polynomial. So next type is polynomial function. In polynomial function, here you have to define the function f from set of real number r to set of real number r such that f of x is a polynomial. So in general we will write the nth degree polynomial. You know nth degree polynomial a0. What is the form of the nth degree polynomial? You will write from the constant a0, then a1x a2x square plus an x power n. This is a polynomial. This is a polynomial of degree n. You know from previous classes the general form of a nth degree polynomial. Now what is n here? N is a non-negative integer, and what about this a0, a1, a2 up to an? These are all coefficients and these are constants. So you write here a0, a1 an belongs to your set of real number r. You can take any real number. Okay. Then for example, if you will write a function f of x equal to 5x plus 3, 5x plus 3, or you can also write like this 3 plus 5x. Now this is a linear polynomial. Why it is a linear polynomial? Because the degree of the polynomial is 1. Here degree of the polynomial means the highest power of x. Here how many unknown terms are here? This is your constant term, this is your a0. In this case a0 is 3. Then this is a1x, this a1 is your a1 is 5, and here x means x power 1. So since the degree of the this term, this polynomial is 1, so you can say this is a linear polynomial. So this is an example of a linear polynomial. Then similarly you can give more example for this. If we write suppose function gx, another function gx, it is equal to x cube plus 8x plus 12. Now you see this is a cubic polynomial because the degree of the polynomial is 3. So you can write this as a cubic polynomial. This is your a0, this is your a1, this is a2, that is coefficient of x3. So in this case this you can write like this also. If you are confusing, so write like this 12 plus 8x plus x cube. So in this case based on the polynomial form, in this case your a0 is 12, this is your a0, coefficient of x that is a1, and here coefficient of x square term is not here. So you can write a2 equal to 0, then x cube, that is the coefficient of x cube is a3, so a3 is here, x cube here 1. Okay, this is a cubic polynomial. Then in this way you can give more example based on the degree of the polynomial. If n is 2, that is a quadratic polynomial. So if we will write the quadratic polynomial, suppose h is equal to, we'll write x square plus 5x plus 6. This is an example of a quadratic polynomial. And if from this, similarly you can find your a0, a1, a2. a0 is the coefficient constant term, a1 is the coefficient of x, a2 is the coefficient of x square. So this is a quadratic. Why quadratic? Because the degree of the polynomial is 2. If highest power or degree of a polynomial is 2, that is a quadratic polynomial. Now another example let me give, and you will decide whether it is a polynomial or not. Another function, suppose you will write a function say ux equal to x power 2 by 3 plus 9x minus 1. Is it a polynomial? It is not a polynomial. Why it is not a polynomial? Because in this term the power of x, that is 2 by 3, so n equal to 2 by 3, which is not a integer, is not an integer. So because in the polynomial definition we discussed the degree of the polynomial is a non-negative integer. In this case n equal to 2 by 3, which is not an integer. Therefore ux is not a polynomial. Ux is not a polynomial. Then if you want to draw the graph, in particular you have to take a polynomial. In general, nth degree polynomial, here we cannot draw in Cartesian coordinate system, means in plane, considering two axes. So in particular we have to take an example of, say, suppose f of x is a polynomial of this type x square. So f of x equal to x square, where f is from R to R. R is a set of real number. So in this case it is a quadratic polynomial, you know, because the degree of the highest power or degree of the unknown is 2. So if you want to draw the graph, for this what you will do, as before we discussed, first you have to take the values of x, some values of x, then accordingly you find the value of f of x by this rule, by this formula, by this function. So f of x equal to y a x square means f of x equal to y, so y equal to x square, so y here it is equal to x square. Now take some values, say minus 3, minus 2, minus 1, 0, 1, 2, 3. So if x equal to minus 3, what is your y value? Means f of x value, f of x equal to y, that is x square, so it is 9. So when x equal to minus 2, it is 4, x equal to minus 1, its square is 1, x equal to 0, y is 0, x equal to 1, also 1, when x2 it is 4, when x3 it is 9. So based on these tabular values, based on these x and y values ordered pair, you can draw the graph now. For this x and y value, you have to consider two axes, x axis and y axis, that is a Cartesian coordinate system. Considering the x axis, this is x o x dash, this is y o y dash. Now you take the values, this is 1 2 3 4 5, here -1 -2 -3 -4 -5, here you take 0 1 2 3 4 5 6 -1 -2 -3 -4 -5, like this. So x is -3, y is 9. First order pair is -3 9. So when x equal to -3, y is 9. Here we have drawn up to 6. So if we will decrease the size of the unit of these values in y axis, you can get your 9 here. Suppose let us draw this again so that I am not confused. So this is 1 2 3 4 5 6 7 8 9. Now -3 9 is here, 9 is here, -3 9, x is -3, this is your x value you will take from this -3, and 9 y is 9, so this point. Then -2 4, next is -2, this is your in the x axis, this is x value is -2, so here it is -2, y value is 4, so here -2 4. Next is -1, x is -1, y is 1, -1 1. When x is -1, y is 1. Then 0 0, next point is 0 0, so this is your 0 0 point. Next is 1 1 2 4 3 9, 1 1 2 4 3 9. So 1 1 2 4, then 3 9. Now if we join these points in your free hand, you will get a graph like this. And you know what is the graph? Previous classes you know parabola, ellipse, hyperbola, all these things you know. So this is nothing but a parabola. Parabola along y axis, open upwards. So you will write here the graph is a parabola along y axis, open. Parabola passing through origin here, see, passing through origin, the parabola is passing through origin, you can write here also, parabola passing through origin along y axis, open upwards. Because previous classes you know parabola along x axis, what is the equation? Parabola along y axis, what is the equation? Parabola left side, x axis left side, x axis right side, what will be the equation? Similarly, the parabola is along y axis and open upwards, and parabola along y axis open downwards, accordingly the equation will be changed. And here our equation was y equal to x square. So that means, in other words, we can write x square equal to y. X square equal to y is nothing but the equation of a parabola along y axis and open upwards. You can find the focus, everything, whatever you know, you can find here, but here it is not necessary. And next, in this case, if you want to find the domain, what will be your domain? Domain of the function. Because we have defined here the function from R to R, real number set R to R, so domain is R, codomain also R, codomain of the function also R. Now if you want to find the range of the function, So range of the function is nothing but collections of all the images. So images here in this case, whatever value you are taking for from x means from set of real number r, you are getting y, that is x square, means is a positive number including 0. So you cannot get the y value as negative because it is the square of x, and you know square of any number it cannot be negative. So either it is positive or it is 0. So based on that, so your image will be always a positive number because your y value is of the form x square. So your y is nothing but the image of this x. So collections of all the image, that is your range. So range is always a, in this case, always positive number or 0. So you can write the range is nothing but r plus union 0, or in other words you can write it like this: 0 including 0 to infinite, but infinite you will not consider, 0 to infinite. Now similarly you can, this is another one homework for you, you find the graph of the function f of x equal to x cube. Homework for you, draw the graph of the function f from set of real number r to set of real number r such that f of x equal to x cube. Also find domain, codomain and range of this function. You try to find. If you will find any doubt, post in comment, I will solve. Range of this. Yes, you try to come solve this homework. After this, next is your rational function. As the name suggests, rational function, you know rational number, any number of the form p by q, where p, q belongs to your set of integers, and the q, which is the denominator, that is not 0, not equal to 0. Similarly, any function, a function h from set of real number r to set of real number r such that if f of a if h of x is of this form, f of x by gx, where this gx is not equal to 0, gx is in the denominator, the function gx is in the denominator, so gx not will be not equal to 0 because any number by 0, that is meaningless. So where this gx is not equal to 0 for x belongs to r. And what about this fx and gx? Fx and gx are polynomials, So if your function is of this type, then it is called, then hx is called a rational function. Now you can take an example. Suppose a function f of x, it is defined f from r minus 0 to r such that f of x equal to 1 by x. So f of x equal to 1 by x, this is a rational function. So this is your numerator function, this is your denominator function. So that means this 1 by x here. Otherwise, if you are confused, you write this is h. This is your h. So in this case, see this fx is 1, gx is x. Here f of x equal to 1, which is a constant function, and this gx is x, which is a linear function. Gx is x, which is a linear function. Now if you want to draw the graph of this function, then what will be its graph? Let us draw the graph of this function and also find the domain, codomain and range of the function. So now make a table. This is your x and this is your f of x, which is equal to 1 by x. Now take some values of x. So if it is minus 2, minus 0.5, minus 2, minus 1.5, minus 1, minus 0.5, then 0.25, 0.5, here take another value, say 1. So for minus 2, when x is minus 2, 1 by minus 2, that is minus 0.5, when x is minus 1.5. So you calculate 1 by minus 1.5, that is your minus 0.67. When x is minus 1, y is minus 1. When x is minus 0.5, you calculate 1 by x, that is minus 2. When x is 0.25, what is 1 by x? It is 4. When x is 0.5, it is 2. When x is 1, it is 1. So in this case, what will be your graph? So collecting all these x value and y value, you need two axes, that is your x axis, y axis, y dash, x dash. This is your origin. Now you take some values here. Say this is your 0.5, this is your 1, and this is your 2. This is minus 0.5, this is your minus 1, this is your minus 2. Similarly, here you take this is as 0.5, this as 1, and this as minus 0.5, this minus 1, and this as minus 2. Now if you want to draw the graph, see when it is x is minus 2, y is minus 0.5, minus 2 minus 0.5. See here, minus 2 minus 0.5, this is the point. When it is minus 1.5, the y is minus 0.67, minus 1.5, where it is lies, you see here, minus 1.5. When minus x is minus 1.5, y is minus 0.67, means here minus 0.67. So this is minus 0.5 and this is a 1.5, and here just lies over. Yes. Now similarly, when x is minus 1, y is also minus 1, minus 1, minus 1. See, x is minus 1. Sorry, here. This is when x is minus 2, y is minus 0.5. This is minus 0.5 is here, minus 0.5. When x is minus 1.5 here, y is minus 0.67, means in between this here, say this point. Now when x is minus 1, y is minus 1, minus 1, minus 1. This is minus 1 and here it is minus 1, minus 1. Then next is minus 0.5, 2, minus 0.5, 2. This is minus 0.5, this is minus 2, minus 0.5, minus 2 here. And similarly here in this case, positive value 0.254, 0.25 is here. When it is 0.25, y value is 4. Say suppose 4 here. This is 2, this is 3, this is 4. 0.25, this is 4, this point. Next 0.5, it is 2, 0.52, this is 2. Now when it is 1, it is 1. Means in this case, if you join, the graph is like this, and here this case the graph is coming like this, and here if you want to find more points here, you will get like this. So this is your graph in this case, and the graph here it is like this. So this is the graph of the function of f of x equal to 1 by x. So in this case, what is your domain? Domain of the function is, as already we defined, the function takes the value 1 by x. So x cannot be 0, so domain is r minus 0. And here codomain, because we define the function r minus 0 to r. See question. So codomain is r. Now if you want to find the range of the function, so what is the range? So range will be excluding 0, all other values. It cannot be 0 because your f of x equal to 1 by x. So this value can never be 0. It will be 0 when x is infinite. What x infinite will not consider here. In the real number set, infinite is not included. So range of the function is excluding 0. Excluding 0 means you can write minus infinite to 0, open bracket, union 0 to infinite, open bracket. So this set, this is your range set. So if you let me write here clearly the range of the function. Here is a little bit confusing. Range of the function here, let me write clearly. It is 0 is not included, so excluding the 0, rest numbers from the real number set, that is minus infinite to 0, open bracket, means minus infinite 0 are not included. Union, because you know union we defined in the set chapter, union 0 to infinite. So it is the range of the function will take negative real numbers and simultaneously positive real number, but 0 will not be included. Okay. So thank you. Next class you try to complete the read, go through this whatever you discussed, simultaneously try to solve the homework. If you doubt, then you can post in comment, I will solve. Next class we will discuss some more types of functions. If you have not subscribed my channel, you may subscribe. Thank you.